Welcome back to the conclusion of our lesson on change of basis. So we're going to try one more example here. And first off, we're going to pick a vector W, and we're going to do this in the IJ system. I'm randomly going to pick the numbers -2 and 3. Okay. We're going to let B be this basis. U1 is 0.6, 0.8, and U2 is -0.8, 0.6. And we'll let B prime be, V1 is 0.28 and 0.96, V2 is -0.96 and 28. What's special about our B basis? Well, you will notice that in this case, if I do the inner product here, I get 0, so they are orthogonal. Oh, and even better yet, if I take the magnitude of vector 1, U1, I will get the square root of 0.6 squared plus 0.8 squared, which is square root of 0.36 plus 0.64, which is 1. So this basis is orthonormal. Okay? And you'll also notice that this basis is also orthonormal. Okay. Now, let's find the coordinates of the W vector, which you just made up in IJ coordinates. Before we can create a Italian to Spanish dictionary or vice versa, Spanish to Italian dictionary, we need to convert to our foreign language, our non-standard basis. So if I take -2, 3 and write him as a linear combination of these guys, so -2, 3 is some constant multiple of 0.6 and that would be 0.8 plus K2 times -0.8 and M2 times 0.6. And when I solve that system, I find out that the coordinates of the point -2, 3 in the xy plane, when done with respect to the U1, U2 basis, it turns out to be 1.2 and 3.4. Okay. Similarly, if I take this guy and I write him in his coordinates with respect to the B prime basis, those turn out to be, I'll save a little bit of time here, 2.32 and 2.76. Okay. So just as a quick note, -2, 3 is equal to the same pointer location as 1.2, 3.4, but with respect to the B basis, but that is also the same thing as 2.32, 2.76, but with respect to the B prime basis. Okay. Next up, we want to find the transition matrix from B to B prime and B prime to B. Okay. I went ahead and found those. So the transition matrix from B prime to B is this guy, and the transition matrix from B to B prime so this is going to take us from B to B prime. Okay. Now, something that would be really nice to do just to make sure you got everything done is let's go ahead and take our -2, 3 that was in English, we'll convert them to Italian, and then let's use our dictionary that goes from the B prime basis to the B basis and confirm that when I change these coordinates from the B prime basis, I end up with the coordinates from the B basis. Okay. I have this matrix here in my calculator, as matrix H. Okay, so there's matrix H, that's this guy. And in matrix I did his coordinates with respect to the B prime basis. Okay, so let's see what happens if I do matrix H times matrix I. So if I take this guy and I multiply by the, oh, I guess I better do it in blue. So, whoops, that's the wrong blue. Let's take this guy, and if we multiply onto the coordinates, the B prime coordinates of 2.32, 2.76, those were the B prime coordinates, I get back the coordinates of 1.2 and 3.4, which just so happen to be the coordinates of that same location, but with respect to the B basis. So the thing that two things that I want to make sure you keep track of are which direction your matrix goes, okay? And then if you're going to use a transition matrix from a transition matrix between two non-standard bases, such as these two guys, neither of them is the IJ basis, then make sure that you convert your IJ point into the desired language, the desired basis, and then use the transition matrix that changes from that basis to the other basis to find the correct coordinates. Okay. And lastly, hopefully you notice something about our two transition matrices here. Okay. So here was matrix Q that goes from B to B prime, and this was matrix P, which goes from B prime to B. You notice that they're related, and in fact, they're not exactly the same because of the negative sign, but we'll know that we notice that the P transpose is equal to Q matrix, okay? And remember that the Q matrix was equal to the inverse of the P matrix. So that tells us that the inverse matrix is equal to his own transpose. Something we'll take advantage of in the next section.